transformations. It's going to save you a ton of time this year having a good general idea of what the graph looks like. A lot of the times I'm not necessarily going to ask you to give me a real accurate sketch of it, but just knowing what it looks like is going to save you so much time. And so if you remember from advanced math, we went through some of the basic parent graphs like x squared and x to the fourth. Obviously x to the fourth I missed a little bit there. Sorry, it should be hitting at 0, 0. But x to the third and x to the fifth also very similar, although x to the fifth, as you can see, is kind of steeper. Same thing with x to the fourth, just a little steeper of a parabola than x squared. And then some of the rest of the parent graphs that we have, we've got the square root of x. That's a good one to know. Absolute values is that v. And then 1 over x has those asymptotes that I have in red up here, horizontal and vertical, and kind of end up in those first quadrant and third quadrant. Okay? So again, that's a quick recap of some of those parent graphs. And what we're going to do is just move them around just a little bit with some of these transformations. One of the easiest transformations, it's a way of moving it or flipping it or changing it. And then, so those parent graphs, you could leave those in your binders wherever you want. Then this is actually the notes here. So a reflection is basically, and it depends on, well, something's a little off there, I'll fix that. Basically this negative you see is, I would consider this one kind of being on the outside, and all that does is it takes your original graph and reflects that parabola, and I'm just using x squared here. It takes that and reflects it over the, as it says right there, x-axis. So again, it would take that one right there. So it would start at the black one and basically end up as the red one is what it would do. Okay. That's all that particular transformation would do. Again, the black one would no longer be there. If I was doing negative x squared, it would just be the red one. Because all it did, took the black one, flipped it over. Slight typo on this one, the squared should be on the outside. You see how the negative x is inside the function there? And so the squared should be on the outside, so fix that on yours. And that actually reflects it over the y-axis. Well, x squared probably wasn't the best choice to show you something that reflects over the y-axis. Because if it reflects over the y-axis, it reflects onto itself. Does that happen with, say, x to the third? Is that gonna be how that works? Not really. If you have x to the third, it starts there, correct? And if I reflect it over the y-axis, basically, do you agree that's where it would end up? But again, this one, yeah, it's just going to sit right on top of itself with your x squareds, all right? So that's kind of what will happen there. So watch out for those. This one does not happen a lot, this one where the negative's on the inside and then you have to square it or cube it. Doesn't happen too much, but just watch out for it, because I'm sure I'll throw it in there at least once somewhere. So any questions on the two reflections? Basically just a negative put outside. And when I say outside, I mean not being squared part of the function, or maybe the negative being thrown inside. Okay. These are probably the ones that, if you remember, what happen the most. Move it up, down, right, left, all that kind of stuff. And again, I kind of consider this C here is just for a constant. That's all that stands for. And I consider these being outside, because it's not, in this case, being cubed with 2. And so if it's outside, it's very straightforward. It's either up or down. And if it's a plus 2, you just move it up 2. That's all you got to do. Basically because the y value just got 2 bigger than it was before. You took your old y value that you had before and added 2 to it. So the y value got 2 times bigger. So in this case, you may start with that one, and maybe perhaps that's moving it up 2 for this instance. So you wouldn't necessarily have that black one. And again, what point was the easiest one to move up to? The point 0, 0, and then just kind of get a sketch on there. All right. So basically, we took 0, 0, moved it up, perhaps 2, and there it is. Again, the black one would no longer be there. That would be your original. And so that red one there is x to the third plus 2. On this other one, it's a negative 3. It is outside, though. So my parent graph is x to the third, so it's that cubic graph. But in this case, it is a negative 3 being outside, and so perhaps that's moving it down 3. Again, the black one would no longer be there. It would just be the red one at that case for x to the third minus 3. Because the black one's just x to the third. Okay, any questions on that? So again, I consider those outside. You know, they're not being cubed or square rooted or squared or anything. And this is where, for those of you that kind of forgot inside outside, this helps a little bit because now you can see that that 2 in this one actually is kind of being taken to the 4th. This is inside. And this holds true however far you go in math. You ever see something inside parentheses taken to a power, you can 99% of the time think of it as being the opposite of what you expect. And I'll explain why that works that way. Because you're looking here, this is inside. You would think that should move it to the right too, because inside is right or left. You would think should go right too. But it's the opposite, because what number, because remember the point we're working with is 0, 0, right? That's the point we want to be moving. And so what do I have to put there to get back to where I started? You have to actually put in a -2, right? That's why those are the opposite of what you think. And I don't have to do that on those other ones, all right, where it's outside. And so that way this one's actually left 2. Okay, so you just take that original and perhaps that's left 2 right there. So that would be x plus 2 to the 4th. And notice I have that taller parabola this time because it's x to the 4th. Okay? Or it goes up quicker. Apparently, it's 2. Moved it over. Again, it's at 0.00. So this one here, again, I consider that inside. And so it's a -1. And so inside's always the opposite. And again, inside's right or left. And so that one's going to be moved to the right 1. Well, I moved it maybe a little bit more than 1, but I want to make sure you could see it. Again, in all these cases, if I'm graphing the one that we have on here, that black one would no longer be there. I'm just kind of leaving the parent graph in there for you to see it. Okay, so we've done reflections, and we've done translations. That's what these are called. Up, down, right, left. Oop. Dilations. Dilations kind of getting bigger or smaller is one way you could look at it. So basically, they're not adding some number now they're multiplying by some number, and that's why it's different. And so they're saying if you multiply by something that's bigger than 1, for example, here we've got 2, well, what is that going to do? What's it do to your y value? It makes it twice as big as what it was before, right? And so what's going to happen here, I think I have them in there. I don't know, maybe I don't. Yep. It's going to go up twice as fast. Okay? And I think I showed you this before. For example, if the point used to be, say, here, and it was only going up 1, now it's going up 2, okay, for a y value. Okay? I know some of you said kind of stretch it, or you use those words, okay? Stretched it, shrunk it, whatever words you like to use, it's fine. And then, well, if something bigger than 1 does that, notice here it says from 0 to 1, not including 0 or not including 1. So there's 1/2. That's probably the easiest example. Well, your y value is going to go up half as fast. Okay? And some of you, I think, use the word smushed or something like that on these. Okay? Because if the y value used to be 1, now it's only 1/2. Again, when I say used to be, that means in the original. In the parent graph, if it was 1, well, now it's only 1/2. And I believe I asked these questions before, but we'll see if you remember. How come they're not talking about 1 itself? Yeah, if it's 1 itself, it would just be the same graph you started with. It's not going to dilate it at all. But how come they stop it at 0 then? How come they don't go beyond 0? I think why they don't use 0 itself is obvious, because 0 times anything is 0. But how come not other stuff? How come say not -2, -1? How come those aren't on there? Yeah, the negative's the reflection. The negative's already been taken care of in the very first thing we did. Okay, so that number just stands alone. That negative will reflect it for you. Does that make sense to everybody? That we did the negatives already? Right here? Okay, and that first one? Okay, so that's why we don't have to worry about those. Well, let's try a few. We'll start off with some pretty straightforward here. I don't know if I have the answers in there, but we'll find out in a second. So what's going to happen? There's my parent graph. Is that the correct graph? Should I just leave it there? We're done? No, what do I got to do? By down 1. It's outside and it's -1, and if it's outside, it's just whatever you think. I don't know if it's in there or not. Nope, apparently I'm just going to move it. There you go. And so now I'm taking that parent graph off. That must have been my thought behind this, so that you can actually see just the graph. Okay? So is number 2 the same thing then? But it's a -1. Ah, but it's inside, so? Right, yes, it's opposite. Yep. So to the right 1. And again, remember, what point am I really trying to move is that 0, 0 point. So just kind of move that over, get close. Again, the idea is so that you have a really quick picture of these, at least in your head, or you can get a real quick sketch of these without having to sit there all day and think about it. That's the whole plan here. Well, actually, were there any questions on those last two? Okay. Well, what did I do here for number 3? Oh, sorry. Well, I slid it a little bit. That's why I was saying it's kind of hard to see. It was right here. And I just slid it. Just kind of looks like it because it gets so shallow by the axis there. Yeah. Nope, no problem. So what did I do with number 3? Yeah, I did more than one thing. And that can happen. Almost all of these can happen at the same time. Obviously, you know, up and down is not going to happen at the same time. But this one, again, we have 2 translations. It doesn't matter which one you want to talk about first. Most people like to talk about the +3 first because that's outside. So that moves it up how much? 3. So, you know, you just do the best you can. 1, 2, 3. So should I leave it right there? That's good? To the right 1. Again, you just kind of get close. You know, get it so that it's kind of hitting 3, 1 there. Just get close. And I'm not going to sit there and measure and make sure your arc is perfect and all of that stuff. Because if I remember, some of you struggle with the cubic graphs slightly. Oh, number 4, we haven't talked about the absolute value graph very much. It is that V. So is that +1? Is that inside, outside? And how's that work? Yeah, I've heard a lot of different answers. So let's answer this first. Is the +1 inside or outside? It's inside. It's inside those absolute values. For outside, you would need something out there. All right. So that is inside. Inside is right or left, and it's the opposite of what you think. And so this one's going to move left 1. That was a little easier to see than the cubic. You can see exactly where that point ends up. Any translations for number 5? Up, down, right, left? Oh, it's a dilation. Am I going to make it, whatever word you want, taller, shorter, I don't know, whatever, stretch, shrink, I don't know, whatever word you want to use. I think this one, did I actually put it in there? Nope, apparently I did not, but I left them separate. So what's going to happen basically is the slope kind of used to be -1 at this point. Now it's going to be, the slope's actually going to be -2. Do the best you can. It's not going to be perfect. The slope here used to be a +1. Now it's going to be a +2, give or take. Or if you really exaggerate that, I'm fine with that. The V kind of just goes up faster. Okay. And I think I might just graph this next one on my own. I don't know if I have it in there. But what's going to happen to this one? The -3, inside, outside. It's outside, so that moves it down 3. And how about it is dilated, so it gets wider, but what about that negative? Reflects it. Okay, so there's a lot going on. I hope it's in there. And it's not. All right. So we just go down kind of about to -3. Okay, that's really bad, but you get the idea. It got wider out this way. It got reflected over the x-axis and moved down 3. So actually 3 things happened that time. Okay, got reflected, and a lot of times I kind of do the reflection first in my mind, then start moving it around. It's a little bit easier. Okay, any questions on that?